and our speaker, Dr. Shailendra Kumar. I welcome all of you to this national workshop on innovation and sustainability in food processing. To start with this today's session, I would like to request head of the department and the chairperson of this workshop, Dr. V.K. Modi, to express his welcome address for today's session. Dr. Modi, over to you.
Yes, thank you, Dr. Soumya. Uh, I from the it's great pleasure for me to welcome our today's speaker, Dr. Shailendra Kumar, from myself and from the MIT Institute of Food Technology. This workshop it is designed for specifically for the students' knowledge only. So we have a series of the speakers, and it is been spreaded in 6 or 7 days continuously. Every day, some few hours we means conduct this workshop, and our all students, BTech or MTech or MSc, all they join, and of course some means MIT faculty also they are the attending this workshop. So as a just brief introduction about my institute itself, the at the MIT Institute of Food Technology, it was initiated in 2008 with the subject of the BTech Food Technology, and now at present we are running 4 or 5 programs: BTech Food Technology, MTech Food Technology, MSc Food and Nutrition, PhD Food Technology, and PhD Nutrition. And just 2 years back we also started BSc Home Science also. So with this, now we have a student strength around 400 plus, and our most of the students they prefer to join the industry only, and they are in the all spread it throughout the country. And a few students, of course, they join the research arch and the higher education, and they are in some European universities or American universities. So we earlier also we had a few speakers from Mother Dairy itself, and they have enlightened about the concept of this dairy and the food technology. Because students they are little bit confused about that dairy technology is a separate subject than the food technology. So they have in their mind that dairy industry they absorb the BTech dairy technology people only, but it's not that question here. So I try to, because these questions arise during my conversation with the students. So then I try to explain that there is no, see, food technology, of course, dairy is a one specialization. If you do your BTech in dairy technology, you will be totally only exposed about the dairy or milk, whatever it is. But in food technology, of course, you are touching as a food subject. So basic principle remain the same. So with this today, I welcome our speaker today, and so definitely our student will get benefit from your valuable thoughts. So over to, with this, I over to Dr. Soumya, please.
Thank you, sir. Thank you for the welcome address. And now this is it is the time we can move ahead with our session. And before we start with the session, I would like to give a brief introduction about our speaker today. So our speaker is Shailendra Kumar. He is a DGM Corporate Quality Assurance, and he is having 29 years of long industrial experience. So it is really pleasure to have you, sir, with us today. And dear students and participants, we are really fortunate to have such a senior industrial personnel for this particular workshop. I hope the session is going to be very much fruitful for us. And for today, Dr. Shailendra Kumar is with us with the topic innovative hygienic equipments and building design floor for dairy plants. So with this brief introduction, I would like to request Dr. Shailendra Kumar to take the floor and enlighten us with his industrial experiences. Over to you, sir.
Thank you very much, Mr. Somaya, for such nice words. Uh, Good morning, everyone. Good morning, friends, especially the students who are there. I am very uh, enthusiastic to speak to the students. But before that, I would like to thank Dr. V.K. Modi and Dr. Balwinder Shukla for organizing such a grand event. And I am thankful to Dr. Monica Thakur and Dr. Renu also for inviting Mother Dairy to experience, to share our learnings and experiences. Uh, so I welcome you all in this today's session of mine, which is on advanced hygienic equipment and building design for a dairy plant. So of course, I have written dairy plant, but don't worry, it would be in general for the complete food industry. So as Dr. Somaya was saying, I am in dairy from last 10 years, but earlier for 20 years, I worked with PepsiCo franchisee unit. So I have a complete experience of beverages. I have experience with horticulture and I have experience with edible oil and dairy. So it would be let me assure you that it would be a complete food sector presentation and not limited to dairy. Of course, specialization in dairy would be there. So moving forward, so the content which I would be covering is on hygienic building design for food factory, hygienic design for pasteurizer and its control, prevention of cross contamination, cleaning in place, that is CIP, and the preventive measure which food industry has adopted during COVID-19 scenario, which is very important to tell our customers that how safe the food which we are delivering to them is. Okay, so I request the students to make it more interactive. Wherever there are questions, they should ask. I would be very much happy to answer your questions. And then only this workshop would be we give some fruitful results. So moving forward, why we talk about this hygienic equipment and building design. So if you see in the recent or the historical events also, there were outbreaks due to hygienic engineering failure in the factories. Okay. So earlier when our mother used to make food for us, so it was at home and we are very much sure that the hygiene is guaranteed. But now when we are making food in the industries, in the big industries, automated industries, so there we need to take those necessary precautions and care of equipment design and building design to deliver the safe food. However, when we see the historical events, there were outbreaks like in Bluebell ice cream in USA, there were 2 outbreaks of listeria contamination due to hygienic design issues. Similarly, on the second slide, you see there was a light contamination in a Chinese dairy industry. It was a small valve which malfunctioned and the caustic went into the milk. So there were outbreaks, there were deaths, there were casualties, and there were those recalls with the product. So that kind of scenario is there. That's why this is very important. Now, talking about the building design, hygienic building design for food factory. First of all, we look for the location and the surroundings. It should be away from the environmentally polluted area and it should be away from industrial fumes, excessive soot, smoke, dust, biological emission, pollutants, etc. So it is very important to see where, when we select the location to put up an industry, especially a food factory, we have to see the surrounding areas as well. We have to see the groundwater quality. whether the groundwater, because water will be used in food industry. So groundwater quality should be tested. It should be tested for complete 10,500, IS 10,500 requirements, like physiochemical, microbiological, as well as uh, the contaminants which can be there but not cannot be tested easily at the labs of any food factory. So those samples need to be sent to Bark lab, that Bhabha Atomic Center, Research Center, there for the test for those pollutant can be done. Now, looking at the exterior site structure, okay, so landscaping, the vegetation, although we say vegetation is important, but when it comes to the food factory, vegetation should not be there because it poses harborage to the pests and rodents. So, if vegetation is there, it should be at least 9 meters away from the building. The floor should be sloped away from the building to ensure positive drainage. Okay, and the building, the food factory building, there should be a pebble strip along with the building wall. That 1.5 feet pebble strip should be there. Why this pebble strip is important? Because it will not allow the rodents and the creepers, they cannot move on the pebble strip. So that's why it is important. As far as the lights are concerned, outside lights are concerned, we should use the lesser UV ray emitting lights like sodium vapor lamp or LED lamp, because the other lights like mercury vapor lamp or metal light, they attract insects. All the doors and windows should be pest proof. Okay, there should not be any hole in the exterior walls, because normally walls are safe, but when we have some entry points like doors, windows, exhaust fan, air intakes, all those, and pipeline which are coming from outside into the building of the factory, those areas have possibility of crevices, holes and gaps in that. So those should be properly sealed. There are designs and there are proven things which are in place which can be put, like strips on the bottom of the doors, like high velocity air curtain on the entry points, windows as well as doors, and like PVC strip curtain, overlapping strip curtain to allow the mobility as well, because every time you cannot keep the door closed. Sometimes when the people are entering or if the material is coming in, we should have overlapping strip curtains to avoid the external air, the external contamination, pests creeping into our factories. Now, this is very important, and it is sometimes ignored. Like the foundation, when we make foundation, it has to be a proper concrete foundation with concrete footing. Now, in absence of concrete, if some people have wood, brick, or other kind of block foundations, there is a possibility of rodent to burrow through those and get entry into our factories. So this is very important. Now, there are pipelines which are coming from the different floors of the factory and going like drain pipes going down into the gutters at the ground level, ground floor level. So there is a possibility of rodents entering through those pipelines. So this is one of the device which is we call it rat stock. So this device is having a sieve inside, mesh inside, and it allow the necessary amount of liquid to flow down also, and it will not allow any rodent or creeper to move up into the factory. Now, on both sides of the entry doors of any factory, we should have rat traps. We call it rodent box. There, inside the rodent box, there are glue traps which can catch the rats if they come. Other than this, there should be a first line of control for the pest. That first line of control is along the boundary wall, inside of the boundary wall of any factory. Then there will be a second line of control, which is along with the building of the factory. You know, outside there is a boundary wall, and then inside there is a building. So I am talking about the boundary wall, peripheral boundary wall. There we should have these kinds of rodent traps, which can take care of the rodents at the first place. So we want to exclude the rodents and other pests. We don't want that they should come into the factory and then we should trap them. We want that there should be a pest proofing, pest prevention. Pet should not come into the factory. Now, why I'm emphasizing on it, because if you see, this is a proven science which we have learned from American Institute of Bakers. They are the pioneers in GMP and housekeeping and food safety inspection all over the world. So if you see, this example has been quoted by them. If you see the door on the first side, on the left side, that door from distance, you cannot see if is there any gap. But if you go near and see that if a pencil can go through that gap, a rodent can go. See, rodent can maneuver its body to move inside from the small holes also. So this, there is a saying, if you want to control the pest, you should know the behavior of pest. You should know, you should be able to think like a pest, how they move, how they do their activities, so that you can control it. Now, talking about the hygienic plant layout, it's a small animation. If you see how in the food factory, when we enter through a corridor, so first it will go to laundry hatch for cleaning store, and then the employee can go to the washrooms, then it will go to the lockers, wear hairnet, then boot wash, then hand wash, hand dry facility, and then they can wear PPE, and then they can enter through automatic double doors into the factory. So separate zones are made. Now zones, why zones are important? Because if you see this slide, I'm sorry, I have not, whether the slides are visible to all?
Yes, sir.
Okay, thank you.
Yes, sir.
Because that visibility is important. Otherwise, I may keep speaking. Okay, if you see at this slide, in the center, there is a red circle. We call it critical zone. Now, what is critical zone? Okay, first I will let you know that we divide. Normally in food factory, we divide our food factory into 3 zones. One is critical zone, other is control zone, and third is clean zone. Now, critical zone is a zone which is most important, where we process and pack our food. Okay, where the highest level of hygiene is required. So we want to protect that zone. That's why that zone is in the inner core of the factory. Now, the door of that critical zone should not open to the environment. Not only the environment, it should not open to the clean zone also. So all the doors of critical zone should open to control zone. Control zone is the next level of hygiene. Okay, where we have other processes like water treatment, like storage facilities and other things. So none of the critical zone door or window should open to clean zone or the environment directly, right? Now, critical zone is also very important, and then comes the clean zone. Clean zone is our within the boundary wall of the factory, where we have washroom, we have other facilities, we have hand hygiene stations, lockers room, all other things are there. Okay, so you see why the zoning concept is important, because when we talk about cross contamination, so we have a different colored housekeeping equipment also, because we don't want to use a equipment, a wiper or a brush which is used in the clean zone. It should not come to the critical zone. So to avoid that cross contamination, this zoning is important. Like for critical zone, we will have a different colored equipment for cleaning, right? And for control zone, it will be different. For clean zone, it will be different. So there would be different color equipments, including dustbins, including garbage bins, including brushes for cleaning, including wipers, everything should be different, so that it is a fail-safe mechanism. No, there is no chance of any cross-contamination. So these are some of the examples of good hygiene station and access controls. Nowadays, they are available with boot wash, with hand wash facility, hand sanitizing. Then they will also have access control. These are the few of the examples of good hygiene practice. These are all building design part. Like you see on the first, there is a cubicle, toilet and cubicle device, which is mounted on the wall so that the bottom can be cleaned. So we encourage these kind of toiletries and the cubicles where all the areas are accessible for cleaning. In the second picture, you see the coving. All junction of any through the wall and the floor are coved. Coving will allow the cleaning, easy cleaning. If the coving is not there, corners, nooks and corners are there, cleaning will not happen. And the third picture is showing the sloped rooftop of any equipment. Like this is a small locker, but on the top it is not, it is sloped so that the cleaning can be done. Now this is the most area which is always means left out. Like in the roof, people do not go to the roof normally. They go inside the factory, they go inside the offices, processing halls, packing areas, storage areas, and then they come out. But these are most neglected areas are the roof, where we see if the roof is not proper, if it is a gravel roof, or if the some pits are there, because with the passage of time, this pitch and gravel roof can generate those kind of pits, and their waterlogging can be there and contamination can come. So on the second picture, you see the standard practice of metal and membrane roof, which is preferred in the food processing factories. Now talking about the flooring, it is very important to have a good floor, because floor is the one which take most of the abuse in the plant. All the equipment, machinery, people all walk on the floor only. Now talking about the floor, it should have 1 inch radius cove at floor to wall junction. That coving is important. Second is there should be 1/4 inch foot slope towards the drain. The floor should be sloped towards the drain. There should be one drain at every 400 square feet floor area. Crevices, pits shall not be present on floor. So it is very important to have floor of proper design. Now, talking about floor itself, if you see, we have seen flooring of epoxy flooring. Okay, there are various kind of floor, tile floor, epoxy floor. Okay, so this view is an electronic microscopic view of an epoxy resin floor, where you can see small pits are there, which are harboring, which can harbor the contamination. So we have to select the proper vendor also, who can give the proper material, proper design, and which has a proper knowledge about that flooring. So then only we can get the right kind of floor, which can avoid the cross contamination from the floor, breeding of the contamination at the floor. Now here one more important point is the junction of the drain and the floor is very important, because at that junction most of the damage occurs, and then water creeps into the tiles or the PVC flooring of the floor, and then the micro contamination and other contamination starts inside the floor, which is not evident from the top. Elevated structures are very important. Elevated structures are very important. Why? Because there are product zones below them. So elevated structures should be, you have, suppose there are lines which are going with different temperature product. So there can be condensation which can fall into the product zone. Now we have to secure the product zone. Why product zone is important? Because first of all, what is product zone? Product zone is a zone just above the product which is on the lower level. Suppose there is a product at a conveyor and on just above that there is a light fixture. So if the light fixture is of not proper design, there is a possibility of that. If in case of breakage, it can fall into the product. Similarly, if the line is going and there is a condensation on that line, so it can, the condensate drop can fall on the product. So that we have to secure the product. We have to design our plant like that. Over the product zone, either there should not be anything, or if it is there, it has to be protected. Now coming to the ventilation. Ventilation is very important. Like we have closed the factory through the walls and doors and windows, but how to bring the proper ventilation in? So there should be on the opposite end of the building of the factory premises, there should be there are various type of requirements, okay, depending upon the kind of food product we are making. Suppose we are making baby food, then there is a different kind of requirement. Then there is a HEPA filter for the air which comes in, okay. But in normally in general food factory where that kind of high hygiene requirement is not there, clean room standard, there are different clean room standards for the air intake. So normally we have a 5-micron filter. All the incoming air should be filtered through 5-micron, and then it should be, there should be one way in, and there should be from the other end of the building it should go out. So there should be a proper ventilation in the factory. So this is a general normal thing I am talking about, okay. Now we can have a positive air pressure depending upon the food product which we make. Like if we are making UHT products, we should have a positive air pressure inside the processing hall, and the air which is coming in should come through a HEPA filter, okay. So why positive air pressure? Because positive air pressure, suppose there is a negative air pressure, so whenever you will open the door of the processing hall, the outside air, the contaminated air will gush into the system. That's why the positive air pressure is required inside the processing hall or the packing areas. Now, another example of good hygienic building design. This is normally you see when we bring in air through the ducts. So those ducts are metal ducts hanging over the roof, and they pose possibility of contamination of dust on them, and pests crawling over them, uneven air distribution throughout entire length. So there are solutions for that, like textile ducts, okay, for air distribution. These textile ducts are hygienic in nature. They can be opened, they can be cleaned, washed, and then refitted. Drains are very important. Drains are the areas which take all the filth, all the load, water, everything, and it goes through them. So drain, I will talk about more on drains. I have a small video also to show you the hygienic design of the drain, okay. So there is a video you can see. So it is sloped towards drain, that it is hygienic. On the left hand side, it is a hygienic design. On the right hand side, it is unhygienic. Now, if you see the junctions where the metal and the floor, it should be able to bear the load, because maximum time it get damaged and edges get damaged and water creeps in. Then that design of the drain should have internal radius larger than 3 mm, so that no debris can stay there. Again, this part also, where the floor and the metal part are missing. So it is a hygienic joint should be, no metal to metal joint should be there. Now looking at the bottom part, you see there is a water accumulation on the bottom, on the left side, and on the right side. On the left side, it is fully drainable. Okay, so normally the areas where CIP cleaning in place happens and a lot of water is coming at one point of time. So these kinds of drains are there. These drains are hygienic drains with a water sealing device inside so that no contamination through the final drain should come into the processing areas. Now these are the lights. If you see on the left hand side, the light design is not proper. They are hanging. There is a possibility of debris, filth, soil accumulation on the structures of light. Okay, and on the right hand side you see the proper design, like lights are integrated into ceiling or the wall. Okay, and if they are not integrated into the ceiling or wall, if they are hanging also, their structure should be sloped properly, or it should be properly covered so that no filth can stay over there. And if something is there, we can easily clean it. So prevention of dust accumulation, easy inspection and cleaning. It is very important. Other than that, the intensity of light, like normally for all inspection stations where the food is processed, 600 lux is the minimum requirement which we say. Now talking about the exterior lights, if you see in this picture, there are one picture on the left hand side where we have the exterior light focused away from the factory building, and on the right hand side we have the light focused towards the factory building. Now if the light is focused away from the factory building, it will attract the pest towards the building. That's why the right direction is of the mast and the pole lights should be towards the factory building. So these are very small points, but they are very important when we design our food factories. Now these are the very difficult to clean areas because there is no space left underneath those equipments which you see. So what is the right kind of distance from the floor? Like depending upon the width of the equipment, if the equipment width is 90 centimeter, the distance from the floor should be 20 centimeter cap, so that easy access and easy cleaning and inspection can be done. Similarly, if there are different sizes of the equipment and different distances from the floor is required. Temporary repair, sometimes it is very, actually there should not be any temporary repair, but sometimes in a running factory it is very important. It is necessary to do some temporary repair to keep on our processing. In that case, if there is a tape repair, there is a cardboard, string, any repair is there, it has to be numbered, it has to be recorded, so that whenever we stop the plant, the permanent solution should be given to that repair, because temporary repair is not advisable. Okay. Gaskets are very important when there are lines where the liquids are flowing. Gaskets are important, and it is very important that gasket should be non-toxic, non-absorbent. It should be able to take the temperature and the acidic or caustic nature of the product, and it should not protrude outside and it should not create any recess or ledges. Okay, so that is very important. Lubricated equipment, it should not be there on the product zone. Suppose there is I have told you about the product zone. So sometimes there are equipments where some shaft is there, some movable parts are there where lubrication is required. So we should design our equipment like that lubricated part should not be there just above the product zone. And if it is there, it should be protected properly with a barrier. This hygienic welding is very important because welding is an integral part where stainless steel or other things are there. Mostly stainless steel I am talking about. So welding joints will be there. So what is the requirement for welding joints? These are the requirements. Like it should have a surface finish of 0.8 RA. Okay, RA can be determined through an instrument called profilometer. Okay, so in normal words, the welding joint should be very smooth. The surface should be very smooth. Okay. These are some of the examples of hygienic design, like in niches and catch pans are there. So on left hand side, it is not acceptable. On right hand side, the designs are acceptable. Some of the examples just to show you. These are more example, like the staircase is a poor and very difficult to clean. On right hand side, there is a space where we can easily clean, properly designed. Now, this is a classical example of a product zone. Suppose there is a staircase above the product zone. Okay, the person is standing on a staircase, and below that, suppose product is moving. So if you see on the right hand side, there is a solid plate, green solid plate on the floor. There is a kick plate on the sides, because sometimes it can fall from the side also. Okay, and the staircase is encased properly. So it will prevent dust, dirt, and harborage of insect, etc. From if suppose the pipelines are coming into the building from roof itself, so that has to be plugged either through a sealed collar or sealant or other things. Any material which is coming into the factory should pass through a sanitizer tunnel or barrier tunnel, okay, where we can use any sanitizing agent as per the requirement. Borewell water, like normally all the factories use water, so and they have borewells, their own borewells. So borewell water protection is also very, very important. Now, how to protect borewell? Suppose there is a borewell which is done inside the factory. So there is a requirement of RCC side cover. Okay. And that RCC side cover, apart from that, on the top also, there should be a RCC done. It should not be left with the mud only. So proper RCC apron should be there, and the borewell casing should come out of the floor level at least 2.5 feet above the floor level, so that the ground water should not go into the borewell casing. And then borewell casing should be sealed from the top. There is a borewell casing and there is an in-between pipe which is coming out of the borewell casing, right? So that pipe and the casing area, it has to be properly sealed. Now that borewell area should be kept in a lock and key area. Okay, so no access. There should be no access to other person. So access control to borewell area should also be there. Now, summary, I have a small video on summary of building design. Whatever I have told, this video covers everything, most of the things. You can just see. So these are the places where bacteria can harborage. Now, this is not the right design. If it is properly sloped, nothing can stay there, and it is easily cleanable also. Another example of any lock. Like this lock is having a harborage area. Now this is not, because nothing can go inside, it will come out, run off. This is another way of showing it. So these are the cable fittings, cable glands. This is not the right design. This is the right design. Without any crevices. Now these gaps in between enclosure body where the liquid can get trapped. It should have a silicon rubber gasket to eliminate the gaps. These are the wall mounting brackets, which are very difficult to clean. So the equipment should be away from the wall, properly mounted. Behind also we can clean, no harborage will be there. These are leveling feet. which are very difficult to clean. So this is a different design, which is a hygienic in nature. So very small things are there, which plays a very important role. Okay, moving forward. Now, EXEDG, that is European Hygiene Engineering Design Group, and 3A, they are the global standards for hygienic design. We can always refer to them. At Mother Dairy, Corporate Quality Assurance, where I am working, we have a small team, and we have studied most of the international and national standards on equipment and building hygiene design for food factory, and we have tried to incorporate most of the things in our plants and other areas in the complete value chain, because not only the plant, there is a back end from where we procure things which goes into the processing plant, and then from processing plant the finished good goes out of the factory to the distributors, CFAs, retailers. So the complete value chain has to be taken care of. So we have to design and develop the requirements, quality and food safety requirements for the complete value chain. Now, when we say hygienic design of equipment, now I am coming to the equipment design part. Building design is over. Now, when we talk about the hygienic design of equipment, you can see a spoon, front view of a spoon, which is quite okay. But if you see the back view of the spoon, so if you go in detail, there are uneven and inaccessible areas which are not, we cannot clean them. Key food processing equipments are found with similar hygienic design issues. Okay, so if you go and see any big big players also who are providing equipments to the food factories, these kind of issues will be there. Now, what are the pillars of equipment design? Like, it should be cleanable to a microbiological level, made of compatible, inert, corrosion resistant and non-porous, non-absorbent material. Okay, readily accessible for inspection and cleaning. No product or liquid collection should be there. It should be self-drainable. Okay, continuously welded, hermetically sealed. There should not be any pit or cracks, corrosion, gap, lap, seams, inside thread, bolt rivets and dead ends in the equipment. Okay, sanitary operational performance. Okay, hygienic design of maintenance enclosure. Okay, maintenance enclosure must be designed, constructed to avoid usage of storage area. Normally people store their things in the enclosures like lockers. They do not, sometimes they avoid lockers and store inside those kind of enclosure where like electrical cabling box and all those things. Okay, so another part is it should be compatible with other plant system. So it should be properly fitted. ऐसा नहीं होना चाहिए उसको किसी तरह से fit किया गया. And last but not the least, it validate cleaning and sanitizing protocols. Moving forward about the pasteurizer and its control, which is the pasteurizer is the heart of any dairy industry. Okay, now the concept behind our functioning is, suppose there is a food safety hazard. Okay, so we have to put a control measure in place. Now control measure can be manual detection and manual control, which was earlier happening. Okay, something is happening, person is watching it and taking action. Now there is another level of it where we say auto detection and manual control. Suppose person is cannot stand there for forever, so we have put some light, some alarm, where the person anywhere he is, he can rush to the spot and do the needful. And then comes the auto detection and auto control, where person is not required. Okay, the machine will take care of its functioning by itself. If there is some problem, automatically it will be taken care of. Now, most of the people are satisfied with this, but we at Mother Dairy do not. We talk about the fail-safe mechanism. Now, what is the fail-safe mechanism? Fail-safe mechanism is that in case of fully automated machines also, there are possibilities of things going wrong. So we design those kind of equipments, those kind of automations where it is 100% ensured that nothing can go wrong. Now, as far as pasteurizer is concerned, so few of the requirements of pasteurizer which are best in class, like pasteurization CCP, fail-safe mechanism controlled by double temperature sensor. I said nothing can go wrong when we talk about fail-safe. So if a pasteurizer is having one temperature sensor and it is showing some temperature, and basis that diversion of unprocessed milk is happening or the forward flow of the processed milk is happening. You know, in pasteurizer, suppose the requirement of the temperature is there. So if the temperature is attained, it will go to the pasteurized milk silo for filling and packing. That milk is okay. But if the temperature is not meeting, it will go back. Okay, it will be diverted back to the balance tank of the pasteurizer for reprocessing. So now in case this automation is there, but in case the temperature sensor is wrong, what will happen? If the calibration of the temperature sensor is wrong, suppose the requirement is 80 degree and it is showing 75, or it is showing 80 but actually it is 75. So that kind of problem can come. So to make it fail safe, we have put two temperature sensor at the same place at a small distance, so that whenever the operator starts pressurization, that equipment, he will see both the equipments. If both the equipments are showing the same temperature, it means it is correct, because it is highly impossible that both will go wrong and towards one side only. Okay, so that kind of fail-safe mechanism. Another part is the holding coil slope should be upward in nature. I will go in detail in each of them. And then there is a positive pressure requirement on the product side of the pasteurizer, and there should be a continuous data logging. This I have discussed in detail, why two temperature sensors are required. Second part is continuous slope. Now, this continuous slope of holding coil, because in pasteurizer, two things are very important. One is time, that is the time which we give for pasteurization, and temperature. So temperature part was the first. Second, this is the time. So holding coil design. First of all, the length of the holding coil, and second, the continuous upward slope. Because if the slope is not continuous, you can see in this on the left hand side, this is the right continuous upward slope design, and on the left hand side there is no slope. So the requirement is upward slope of 2.1 centimeter per meter is the requirement for the holding coil in the pasteurizer. Why? To eliminate the air entrapment and to assure each particle of milk get the desired time. So this is one more picture showing the holding tube upward slope. Even at the bends also, the requirement is there. Now this is FDV. The flow divergent valve is very important at pasteurizer, you know. So how to know when there is a diversion, how to know what temperatures are there, how to know what time is there, what flow is there. So we have to have a continuous data logging system, and we can view through the SCADA monitoring. Now next topic is prevention of cross contamination. Now time is less, I will move slightly fast. So in earlier times there were three-way valves to connect the pipelines and the tanks, because the liquid or the milk or other liquid food, they all travel in the pipelines only. So to eliminate the three-way valve, because three-way valve are not good, they can do the cross contamination, they are not easy to clean. So we use flow plates where the physical separation is ensured. Now this is a journey right from three-way valve to flow plate system, and now flow plate system is also very cumbersome for the dairy which are handling high volume of liquids or the milk. So there we talk about wall battery system, which is an automated physical separation is ensured. Okay, and continuous functioning of the process. One line there is a CIP happening, one line there is milk is going, one line water is going. So it can be automatically ensured through wall battery system. Okay. Now in wall battery system, what is important is the design of wall. because on one line, if you see this picture, on the upper line, red color liquid is going, on the lower line, blue color liquid is there. So there is a possibility of cross contamination if wall design is not correct. So if you see in between those liquid, they are separated by a seal. Okay, a seat and a seal. So here in the wall which design which we are suggesting is double seat mix proof pressure balance wall. When we say double seat, so one seat, if suppose one seat the seal get cuts, there is a possibility of contamination, cross contamination. So we talk about double seat and double seal, and then this becomes a mix proof wall. If there is any leakage also, it will be visible through the center part, and there is a center part which will show the liquid coming down, but it will not cross contaminate. Okay, so operator can take care post the operation is over. Okay, now this is the balance tank of the pasteurizer. Now in this you see there is a divert line. When the milk temperature is not attained, the divert line will come back to the bring back milk to the balance tank. But if that divert line is not connected on the top, if it is connected to the bottom, it can siphonage the raw milk into the system. I will show how. Now this is the complete picture. Okay, suppose the balance tank design is not correct, and if the divert line is touching the milk level in the balance tank, it can siphonage that milk back into the system. And suppose there is a seal cut in the flow diversion wall. So through flow diversion wall, this milk can go to the forward system also in pasteurized section. So that's why we say the diversion line should not touch the milk. They should be above. Now I will show you the standard design of a pasteurizer balance tank. You see all the lines are above the flooding level of the liquid. Okay. So they are 2D. 2D means the diameter of the line, if it is 2 inches, the distance from the above flood level of the liquid should be double that. So it should be 4 inches. And similarly, the drain pipe should be also 2D larger than the incoming pipes. So these are and it should be properly fully drainable, the bottom of the balance tank. So these are the few quick parts which I have shown for the balance tank, which are very, very important. Now, most of the dairies use homogenizers. Other industries, juice industry also use homogenizer. So if you see, there is a current practice in most of the homogenizer where a homogenizer is necessary and bypass lines are provided. Suppose the pressure is not attained, homogenization is done at a higher pressure. Suppose pressure is not attained, till the time the liquid keeps flowing. So on the left hand side, if you see, there is a red color line, which is a circulation line. Now this creates a big dead end into the system. Now on the right hand side, if you see, that wall is placed hygienically and there is no dead end. So if the dead end is there, it should be less than 1D. Now this is the live example of on the left hand side, there is a big dead end on the circulation line, and on the right hand side, it is being corrected by placing the wall in the correct position. Now the other part is the cross contamination control in the pasteurizer. Now pasteurizer is a plate pack arrangement where the liquid milk or the product is separated by cooling or heating medium through a thin plate. Now that thin plate is very small, like 0.6 mm in thickness. So what can happen? Suppose there is a pinhole in that plate. So if the pressure of the cooling medium or the heating medium is higher than the product, it can creep into the product and nobody will know, because we cannot open that plate pack arrangement PHE every day. So what is the way out? The way out is to provide positive pressure on the product side. Okay, and these are the monitoring equipments where we can see the positive pressure, and it is linked to the SCADA also, where we can monitor. Afterward also we can see what went wrong, what went well. Now moving to the next topic, cleaning in place. So CIP is the most important part, if we say, in complete processing area. And we talk about 5T technology. In 5T, uh,
So may
time,
I
temperature.
interrupt you, sir? May I interrupt? Sir,
Yeah,
can we finish within?
Yeah, I will. Give me 5 minutes, I think. 5 minutes are there?
It's already 11:30.
Okay.
So
Okay.
please.
Okay. So time, temperature, tighter, turbulence, and technology. So this turbulence is very important, which is often looked and means which is sometimes is not seen, is not given that importance. So turbulence of 1.5 meter per second is important. So I will go fast slightly because of the time constraints. I will just move through the slides. These are the spray balls. Okay, 180-degree upper, 180-degree lower, and 360-degree. So 360-degree spray ball is important for the industry. So and the spray ball should be on the both side of, if there is an internal structure in the silo or the tank, because otherwise there is a possibility of shadow area and not getting proper cleanliness. Spray ball, we talk about static spray ball and rotary jet head also. So rotary jet head is a latest spray ball available, where with the less time, less temperature, less chemical, with the impact cleaning, we can get the desired cleaning. Okay, so I am moving forward. So we can fight the risk, okay, and damage is likely. We can control the risk, but failure to control will be disastrous. And we can understand, if we can understand the risk, we can rule the risk. So understanding the risk and adopting fail-safe control measures through hygienic engineering shall be the best option for risk elimination. So because time is not there, I am stopping here. Thank you very much for inviting me and allowing me to share my experiences. Thank you. Any questions?
Thank you, sir. Thank you, sir. Thank you for this wonderful presentation. A lot of information were there, and it was not only for the student, for us also, it was really enlightening. So thank you very much for that. So now I would like to request attendees, if they have any question to the speaker, they can post in the question and answer section.
There are some questions. Actually, Shailendra sir, actually participants do not want you to stop. Actually, I am getting so many responses that it is very interesting and so much of information. Sir, there is a question from Zinak Gupta. This is for Dr. Shailendra. What are the additional hygiene measures which have been implemented, keeping the COVID-19 scenario in mind, both in terms of personal hygiene and building layout?
Okay.
Additional hygiene measures.
Yeah, I have few slides on that, but because of time, I will just speak up. So actually, in COVID scenario, there are various measures the industry has taken. Like there are protocols, new protocols which were built in. Okay, so physical separation, that physical distancing of people is ensured by providing the separators in between where the people are working together. So there are separators, the PVC shields are provided in between the working stations so that a person cannot contaminate the other person. Okay, while entering the factory, the temperature of the person is taken, and at the outside gate there is an additional hand wash station and sanitizing stations are provided. Boot cleaning stations are provided, so that if anything is coming, if the temperature is there, the people are sent back to home. Okay, and if they are okay, they are allowed to wash their hands, clean their boots, sanitize, wear masks. Masks they are wearing from home, but we are giving additional mask. We are giving the shield to protect, that head shield and face shield we are giving. Gloves we are giving, and gloves monitoring is increased. Like earlier, the gloves were given, and when they are getting filthy, they were thrown. But now the frequency has been changed. Okay, and every hour the hand sanitizing is being done to the people. Okay, other than that, the complete monitoring like in our factory, we have done the vaccination of all the employees. Okay, so most of the employees who are there at this factory have been vaccinated. So these are the few measures. Other than that, there are some automation kind of things also which we did. Like in the doors, we have put like to open the door, we can open the door through the foot. There is a equipment provided at the bottom of the door where we can operate the door with the foot, not required to open through the hand. Okay, there is a equipment, L-shaped equipment, which is microwell key we call it. So that key can be used to operate anything like opening of door without touching through hands. So these are the few things which we have done.
Thank you, sir. Thank you. There are other questions also. Are there any standards related to hygiene of equipments and manufacturing site? And
Yeah.
yes.
I have covered this, actually I have answered this. There are standards like European Hygiene Engineering Design Group, and there are standards like 3A, international standards, which talk about, they are the international. In India also, we have our BIS standards for equipment, so we can always refer to them.
Thank you, sir. Thank you. Thank you very much.
There is one more question, sir. This thing, yes, sir. No, sir, that is actually a compliment. That very useful information regarding pasteurization from the listening attendees.
Yeah.
They just want to thank you. Yes. Okay, sir.
Thank you very much. There is a lot to share, but time is less. Let's see.
Yeah, and participants are also asking for the video of this lecture so that they can study it.
Surely, surely.
Yeah.
I will see, because there is some information security policy in Mother Dairy. Whatever is possible, I will definitely share. We can connect.
Yes, sir. Yes, sir.
Thank you. Thank you very much for inviting me.
Thank you, sir. Thank you.
Thank you,
Thank you. Thank you, sir.
Thank you.
So dear participants, it was really a wonderful session with Mr. Shailendra Kumar from Mother Dairy. So now we'll be moving to our next speaker. So our next speaker is Dr. Tawhid Amin. He is an assistant professor, junior scientist in food science and technology from Sere Kashmir University, Jammu and Kashmir. So today, Dr. Tawhid has brought to us the topic Food Safety and Standard Authority of India, with special reference to licensing, registration, and labeling. So I hope this will be very much useful for the students and the participants, those who are looking for some kind of startup or entrepreneurship in future. So before we start with the session, let me just introduce our speaker today. Dr. Tawhid Amin is presently working as assistant professor from junior scientist in food science and technology in the division of food science and technology, Kashmir, Sere Kashmir University. He has been food safety officer in the Drug and Food Control Organization, Government of Jammu and Kashmir. He has also been a nodal officer for implementation of the food fortification program in the state of Jammu and Kashmir. He did his PhD in food technology from Division of Food Science and Technology from Sere Kashmir University of Agricultural Science and Technology. He did his MTech in food technology from MIT University, Noida. So it is a proud moment for us to welcome back our alumni to this national workshop. And he did his BTech in food technology from Department of Food Technology, Islamic University of Science and Technology, Avantipura, Jammu and Kashmir. He is the recipient of 2 gold medals for being the topper in BTech and PhD food technology, and has also received the first rank holder certificate during his master's in food technology from MIT University. He has also been awarded with Global Times Writer Award, which is a weekly newspaper from published by the MIT University campus, and he has also been awarded with Best Student Award by the Department of Food Technology, Islamic University during his BTech, and He has more than 100 national and international paper to his credit, and 7 book, and many more contribution to the scientific community. So with this brief introduction, I would like to request Dr. Tauhid Amin to take this floor and enlighten us with his talk on food safety and standards authority of India, with special reference to licensing, registration, and leveling. Dr. Tauhid, over to you, sir.
Thank you very much, sir. First of all, I feel really very honored to have been invited by the university from which I have done my MTech Food Technology. It's really great to be back to the university, though virtually. So I have learned a lot from this Institute of Food Technology. So thank you very much for inviting me. Without taking much time, I'll be starting my presentation. Is it, sir, I have shared the screen. Is it visible?
Yes, it is visible to us. You can make the slides so more.
Thank you so much, sir. Today, I'll be talking about this Food Safety and Standards Authority of India, the regulations, and with special reference to the licensing and registration and labeling part. So my main thrust would be on these three things. So without taking much time, every one of us wants to earn just to feed our families. So we either want job or we want to be entrepreneurs. So the ones who want to be the entrepreneurs, for them, as well as for the people who are doing the job, we have to come out of the comfort zone, and success is waiting for us outside that comfort zone, and we have to struggle. So if we see if we talk about this entrepreneur, he tends to bite off a little more than he can chew, hoping that he will quickly learn how to chew it. So I think government jobs are getting squeezed. So better is for we people to start our own entrepreneurship, especially if we talk about the food technology perspective. We have our country is blessed with such a diverse environment, such a diverse climate, that we have different crops that we grow over here in our country, and we have the potential to start any kind of food business here in this country. So better would be if we can teach our students. Here also we have some incubation centers where we train our students to start the on their own entrepreneurship rather than going for the government jobs. Now, anyone who has thought to be, or who has made his mind or her mind that he wants to be an entrepreneur, but everything is not going to be smooth. We have to stop here because there are government regulations that we have to follow once you go for setting up any industry. And if we talk about the food industries, we have a very vibrant law that has come into force here in our country, that is Food Safety Standards Authority of India regulations, and they have come up in 2006 and got implemented in 2011. Rules and regulations came in 2011. So before moving on to the introduction about the food safety, this Standards Authority of India, if we talk about the food safety, what actually do we understand by the term food safety? It's actually the condition or the practices that we have to perform that preserves the quality of a food to prevent the contamination. There should not be any contamination. At the same time, there should not be any foodborne illnesses. So that's about the food safety. And maintaining food safety is a legal requirement because each and every one industry has to follow the rules and regulations because it is a legal requirement. But apart from legal requirement, I believe that it has to be a shared responsibility. We should not take it only as a legal requirement that legally we have to do this. No, we should take it as we should inculcate in ourselves as culture. Because once we talk about the food safety culture, we should inculcate in ourselves that we have to work, each and everyone, be it the consumer, be it the processor, be it the grower or the producer or any farmer, each and everyone has to work in coordination. Each and everyone has to take it as a shared responsibility so that we can just take our the standards which have been set by our government to the next level, or we can make it at par with the international level so that our products can go into the international markets and we can get a better returns. So if we this is just a quote which has been given by Wingmore. This is: the food you eat can be either the safest and most powerful form of medicine, or it can be the slowest form of poison. So it's all up to us. It is all up to a processor, or all up to a grower, all up to the consumer, that how we take the food. It can be it can be a medicine for us, it can be poison. So that is why food safety is very important. That's why we need to have stringent rules and regulations that should be in place, and that should be implemented in letter and spirit, so that the food that reaches to the consumer is safe and wholesome. Now, to keep a close vigil and ensure the safe and wholesome food reaches to the consumer, Government of India came up with Food Safety and Standards Act 2006. It was enacted in 2006, but the rules and regulations came up in 2011, and it got implemented from that particular time. So if we see the purpose of this Food Safety and Standards Act, it's an act to consolidate the laws related to food and to establish Food Safety and Standards Authority of India. Actually, we had various laws. We had FPO, we had meat and meat products order, milk and milk products order, we had edible oil orders. We have different orders. So in order to avoid those haphazardness, or in order to avoid the ambiguity in that, what government thought, they thought that we should bring all these regulations under one umbrella, that's Food Safety and Standards of India, and we should modify our rules and regulations so that our products can go into the international markets. That was the biggest problem that we were facing previously, but now we are competing with the outside and these markets, international markets. Still, we need to do a lot more is to be done, but we are competing with those. And all of the regulations or the standards that are being released by the Food Safety and Standards Authority of India from time to time, they are all science-based standards. That means if they will tell you that you need to add 0.50 mg per kilogram of any kind of food additive, it's all based on the science. It's all based on the experimentation and observation. It's not because they do have committees, they do have scientific committees which do work or which focus on or which do study, and they just recommend the standards which are being released into the which are being released and which are to be followed by the food industries. And its ultimate purpose is to ensure the availability of safe and wholesome food for human consumption. Overall, all the rules and regulations that we have, they should all work just to achieve the total food safety and quality. Because right from the production up to it reaches to the consumer, it should be all safe. I think I discussed this, the need for such an act, because since we have globalization, due to the globalization, we are treating the world as now global village, and we have to get connected with each and everyone in the international market. So in order to reach to the better to the international markets, this law was enacted. These are some of the activities. I will straight away go to, I will not discuss much about this. I will straight away go to the this packaging and labeling. I think that's very important that I need to discuss. Just a minute. Yes. See, let's first focus on the packaging and labeling. This is Section 23 of Food Safety and Standards Act 2006. According to this act, or according to this section, no person shall manufacture, distribute, sell, or expose for sale, or dispatch or deliver to any agent or broker for the purpose of sale or this packaged food products which are not marked and labeled. So no product should go into the market without marking, without labeling, because we should know the identity of the product. Okay, this belongs to this particular company, this belongs to this particular brand, because if tomorrow there is any problem, if tomorrow there is any foodborne outbreak, so we can just directly see the packet and we can just go for the recall or withdrawal of that product. So that's Section 23. Now, if you see, This is a package, and we have this labeling on the right-hand side, wherein we are labeling it as per the requirement. Now, what are the labeling and packaging requirements that we'll be discussing in the next slides. Now, the important term is number one is date of manufacture, second one is date of packaging. If we talk about the date of manufacture, it means the date on which the food becomes the product as described. That is the day on which we are manufacturing that product, the day on which the food becomes that product as it is described. So that is the date of manufacture, and date of packing is the date on which the food is placed in the immediate container in which it is to be ultimately sold. These are the two terms. Now, very important, which I'll be focusing on, that is the principal display panel. This is actually the area which you see onto the packaging material, because you go to the departmental stores, you go to the shop, and you just see the products which are being displayed over there. The area which is in front of you, which is being displayed in front of you, that is called a PDP, that is principal display panel. So it is that part of a label which is intended or likely to be displayed or presented or shown, examined by the consumer, examined by the customer under normal and customary conditions of display, sale, or purchase of the commodity contained in the package. That means which is for the display in front of you. See, this is the key part, the key parts of food label. If we talk about the key parts of food label, we have the first part is principal display panel. So it is the portion of label most likely to be seen by consumer at a time of purchase. What should be included in the principal display panel? This is as per Food Safety and Standards Authority of India. It's not that you will just put anything you want. No, we have rules and regulations that what should be present on that label, which is mandatory, which should mandatorily be present on that. Number one is the net quantity of content, that is the amount of food in the package. And second one is the name or identity of the product. Like here we have written premium, maybe this can be any brand. Then we should have this amount or weight present. That should be mandatorily present on the principal display panel. This is the principal display panel. As you can see, we have taken a carton. This is any brand. For example, let's say Amul or any kind of brand. And then we have statement of identity. That is, statement of identity means which product is inside. This is cereal based. This can be fruit based. It can be vegetable, beverage, any kind of product. So that is the statement of identity, and that has to be there. Then net weight, that is the net quantity statement. These two things should be there in the principal display panel as per Food Safety and Standards Authority of India Act. Now, the manner of declaration. How should we go for the declaration on that principal display panel? See, all label information shall be given on the PDP manner of declaration. We have a declaration, or we have the rules that have been set by FSSAI, that is called the PDP manner of declaration. And we have to follow that PDP manner of declaration. It's not that you will just cover the whole, you have the bottle which is to be labeled, that you will cover whole bottle. No, there is certain area which is to be covered as per the rules. All information required on labels shall either be grouped together at one place. We can keep it either at one place, or we can just keep it at different places. At that is, pre-printed information would be there at one place and online information in another place. Just like you can see the canned food product. This is a can. We have canned food products available in the market. The area which is in front of you, wherein we have written canned foods, this is actually the principal display panel, because you go to the market and this is the thing which is visible to you. See, this is the real juice that is available in the market. Now we have two areas, or we have two sides of this. Number one is the largest area, which is the front area, wherein we have written real fruit, beverage, orange. Then we have the second area, what we call as smallest area. So area of the principal display panel shall not be less than now we will see what should be the size of principal display panel. In the case of a rectangular container, if we have a rectangular container, for example, in front of you is the rectangular container, that's the real juice. 40% of the product of height and width of the panel of such a container having the largest area. See what we need to do. We need to take a largest area. We will see its height. We will see its width. We have to multiply both, that is height multiplied by width, and 40% of that area should be principal display panel. Okay, so that is the rectangular. Now we have the cylindrical, or we have the nearly cylindrical, round or nearly round bottle. We have bottles. How much area we need to cover as principal display panel? In this case, 20% of the product of height and average circumference. What we need to do, we need to take the height of bottle. But height of bottle is to be taken in such a way that we have to exclude the shoulder height. This bending, the shoulder is to be avoided. So that means up to the point where from shoulder starts, we have to take height up to that. Then we have to multiply it by the average circumference of that bottle. Then 20% of that product of height, that is the height multiplied by circumference, 20% of that should be the principal display panel for a cylindrical or nearly cylindrical, round or nearly round material. Sorry. Now, in the case of container of any other shape, now if we have any other shape that's apart from rectangular shape, apart from cylindrical shape, in that 20% of the total surface area should be there, or we can say it should not be less than 10% of the total surface area of the container. That means 20% has to be mandatorily there, but it should not be less than 10% of the total area. For example, if we have a very big bottle like this, we will keep the small label on that. That means which is less than 10%, it will not be clearly visible. That is why we have to keep it about 10%, or we can say below 20%. So it should be in the range of 10 to 20% for any other shape. Now, how should we go for the calculation of PDP? That's principal display panel. As I told you, for rectangular containers, height times the width. We will take the height multiplied by width of front package. Okay. For cylinder or nearly, 40% of the height times the circumference. That is 0.4. 0.4 means 40%, 40 by 100. Multiplied by height, multiplied by circumference of the container, that will give you the principal display panel. That is the area is to be labeled. That area is to be labeled. Example, to calculate measure around the bottle, the circumference, and not including the slope at the top called the shoulder. It's very important that we have to exclude the shoulder part when we will take height. For other shaped containers, 40% of the total surface area of the container. See, I will show you the example. See, we have those sweets which are like sweets from Haldiram or any other brand. We have those packaging, we have those carton boxes while in the packaging material, while in the confectionery or sweets are being packed. It's a very flat surface. That means it's having a very short height. Now you will have to see what should be the principal display panel. The principal display panel is the upper part. As you can see, the principal display panel, I have shown it on the right hand side, PDP, that is the upper part. Because if we generally, if we see this package, this carton is kept on the shelf, and to us is visible the shortest height, not the largest area. But here you cannot put each and every information. So that is why in this case, it has been made mandatory that on the upper side, that is the largest area size, has to be the principal display panel of that particular packaging material. Then we have, if we have a cylindrical, we have circular cylinder with short height, like for example, Dance. These are the biscuits available in the market. This is having a short height, but it's round. So again, here the principal display panel is the largest area. That is the upper area, because if we will mark it on the short height area, so it will be it will not be visible because its height is very short. So the words will not be visible. They will not be legible, because that is also one of the mandatory requirement for the FSSAI, that all of the labels should be legible. They should be easily readable. So in these two cases, we have to keep principal display panel these two areas. Now, for a small container that holds less than 1/4 ounce, that's almost around 7 grams by weight, or 1/8 oz, that is 3.70 ml by volume, that is labeled with a tag or attached card. If you have a very small volume material or the smaller containers which are holding a very small volume or small weight, in that we are allowed to use the tags or we are allowed to attach the cards, because it's not possible to write each and everything on that smaller container. So we can attach a tag, we can attach a card on that on which the information is to be provided. Then PDP in that case is to be calculated based on size of tag or card it is attached to. So on the basis of size of tag or card which is attached to it, on that basis we have to calculate the PDP. So in determining the area of PDP, in general I'm talking about, we have to exclude tops, we have to exclude bottoms, we have to exclude flange set tops and bottoms of cans and shoulders and necks of or bottles or jars. Then we can calculate it. Now, labeling of pre-packaged foods. If we talk about the labeling of which are already pre-packaged foods, so the general requirements are every pre-packaged food shall be labeled with information as required under these regulations unless otherwise provided. See, when a food product, you see nowadays we have went for this online shopping, especially during the COVID pandemic. We we are online. We are going for the online shopping. We are so in that particular case, how the labeling should be in that particular case, because that's called e-commerce. We call that as e-commerce. So what's more important in that case? What information should be provided? So when a food product is sold through e-commerce or any other direct selling means, the mandatory requirements of the label as given in these regulations shall be provided to the consumer through appropriate means before sale, except batch number, lot number, best before use by date, expiry date, date of manufacture or packaging. See, you will go to the online shopping, you will just see a package of biscuit. You have to buy it. So it should contain each and every information as per the Food Safety Standards Authority of India, except for batch number, lot number, best before, use by date, expiry date, date of manufacture or packaging. Because once you order the product, it's not the product which is being taken from the online, but it comes from a company. So once you order the product, on that particular day, it is being packed, it is being labeled, it is being manufactured. So the packaging batch number, manufacturing number is to be provided on the date once you send it to the customer. It should not be before that. So it's not mandatory that it should be before, except for some of the products, like for example, we have biscuits, we have some other products which are which have a good shelf life. So in that case, it can be there, but it's not mandatory. Now, prepackaged food shall not be described or presented on any label or in any labeling in a manner that is false, misleading, and deceptive. So you should not write anything which is false, misleading, or deceptive. Like you see, we have lots and lots of products in market, and people are claiming them to be anti-cancerous, to be anti-diabetic, to lower cholesterol. So this has been banned now by the FSSAI, because unless it's proved by the scientific evidences, unless they have to prove it by the scientific evidences that, okay, it is having it's a low glycemic index product, it's a gluten-free product, it's lactose-free product. So they have to prove it, then and only they can write. If they will just write it and it's proved that it's not doing that, it is deceptive, it's false, it's misleading. So that means at that particular point of time, he can be prosecuted. That producer or the manufacturer can be prosecuted. So we have to take care of this. Even government also came into force for this. We have actors and actresses, or Bollywood actors and actresses, who are just advertising for many products, and it has been now made mandatory by the Food Safety Standards Authority of India that if they endorse any product to be having any specific health beneficial effect, if later on it is proved to be wrong, they will be prosecuted. So it has been so stringent rules have been made for this, because this way we are misleading. Bollywood actors do come, and what they show, they show us that it is treating this cancer. It's anti-cancerous. So what people are following them blindly, and they are just taking that product. So that is why stringent rules have come in. Even advertisements have been stopped for this unless they are proved. So any information or pictorial device, written, printed, or graphic matter may be displayed on label, provided it's not in conflict with the requirements of this regulation. So you can write anything. It's not, but it should not be in conflict with these regulations. And you cannot write anything what you want, because we have juices available in the market. Manufacturers used to write 100% natural juice. Once you are taking juice from a natural apple, how can it be 100% natural? Because it is processed. Even if we don't add any additive, but it is not natural. So people used to claim such kind of false misleadings. Now this has been stopped. It should not be in conflict with the requirements of these regulations. Or we have products, okay, obtained from the Himalayan mountains, water, spring water directly obtained from the Himalayan mountains. This is misleading, because we are taking water from the we are taking it from the Himalayan region, but you are just processing it, you are just treating it with UV, or you are just treating it with ozone or any other treatment just to make it, or you are adding the minerals if you go for the mineral water. So it should not be claimed, should not be misleading. They will present to you a bottle of water and they will tell you that this has been brought from directly from the Himalayas of Kashmir. This is natural. No, that is misleading. So that should not be done. The particulars of declaration required under these regulations to be specified on the label. It should be in English or Hindi. In Hindi, it should be in Devanagari script, or it should be in English. Label on prepackaged food shall be applied in such a manner that it will not become separated from the container. Label is to be affixed in such a manner that it should not get separated from that container. Because if it gets separated from the container while transit or while transportation, then customer cannot read it, and this is again a problem. There will be again a problem for the manufacturer. So it should be affixed in such a manner. Contents on the labels shall be clear. They shall be clear, unambiguous. It should not be ambiguous. They should be prominent. They should be conspicuous. They should be indelible. They should be readily legible by the consumer under normal conditions of purchase and use. So that's why I told you, once we talked about that Haldiram package, or we talked about the dense of biscuits, in that, in short height, it's not advisable, or it's not allowed to write the principal display panel on the short height, because otherwise it cannot be clear, prominent, conspicuous, or indelible. In that case. So where a package is provided with an outside container. See, we have like, for example, we have a secondary carton, what we call a secondary package. In secondary package, we have the primary package, like we have those digestive biscuits, McVitie's digestive biscuits, those 10 rupees wale packets. They are usually being sold in that secondary cartons, wherein we have 10 packets of those biscuits. So whatever the information is written on the primary package, the same information has to be written on the secondary package. So in both the packaging materials, the information has to be there. Mandatory information has to be there. Except if the packaging secondary packaging material is transparent, then it is not mandatory. If secondary packaging is transparent, because the inner pack, we can see the inner packets very from outside. So in that particular case, it's not mandatory. But if it is not transparent, if it is opaque, in all information that is present on primary package, that has to be present on secondary package also. Like, for example, this is an example. You see on the left-hand side, you have a transparent package. So here it's not advisable that you need to include each and every information on the secondary package. But on the right-hand side, you have the you have those products inside the products. You have smaller packages. So whatever the information is present on the packages which are present inside those packaging materials, that has to be on the secondary package also. Now, labeling requirements. There are some mandatory points that has to be there. Number one is the name of food. Statement of identity has to be there. It should be written that which product is this. List of ingredients. That's again important. Nutritional information, very important. Declaration regarding vegetable or non-vegetable. Declaration regarding food additives. Declaration of name and complete address. See, this is very important, because tomorrow if any customer faces any problem, or if any food safety officer or the assistant commissioner of food safety, they are lifting the samples, then if it comes out to be substandard, or it comes out to be any poisons, or there was any problem was found over there, so the clear name and complete address of that company should be written on the packaging material, so that these regulatory officials can reach to that particular company, and the problem could be solved, or the person could be prosecuted. So this is very important. FSSAI logo and license number is mandatory over there. It should be there. Then net quantity, retail sale price, and consumer care details, they have to be there. Lot number, code number, batch identification, date of marking, labeling of imported foods. Even we have some products which are imported from, which are being imported. So in that, name of the importer or the imported foods, that should have a label. Name of the importer should be present over there. Who is the importer of that product? That has to be mandatorily there. Country of origin of imported foods. So country of origin has to be there, because if there is not country of origin of that particular product written on there, so what will happen? For example, the product comes from, let's say it comes from China. If there is any foodborne outbreak or foodborne illness outbreak in the China, so we can just directly see the country of origin of that product. We can just ban those products for some particular period of time. So it should be there. Then instructions for use, it's not mandatory, but if it is there, if we have a free space over there, you can just use it. Declaration regarding food allergen. This has been made mandatory, because we have people who are allergic to gluten, who are allergic to lactose, so it should be written over there. Or some are allergic to peanuts, soybeans, so it should be written. Now, very important, you see, we have in the market, we have puja water available, because our Hindu brothers and sisters, they just go for this puja, and they do have the puja water available in the market, or they have ghee, which is being used for diya, or they have oil which is being used for puja. So there are some other regulatory requirements for this also, because it should have a declaration on that. There should be a black color cross on the packaging material. That black color cross should be inside a square with black outline. As you can see on the screen, we have a square. Inside the square we have a black cross. So it should be written, mandatorily written, on puja water, on ghee for diya, or oil for puja. It means that it is not fit for human consumption. That it should be mandatorily there. This is a mandatory requirement. And what should be the size? That is as per the principal display panel. We have the regulations 5.4 of C in the Food Safety and Standards Act. As per that, we have to keep the size of that. This is very important. Now, label. Label means any tag, brand, mark, pictorial, or other descriptive matter written, printed, or whatever is written, that will give you an information about the product. We should have a distinguishing mark by which food can be traced in manufacture and identified in distribution. That is lot number, code number, batch number. Because if tomorrow there is any problem, there is any foodborne outbreak, there is any poisonous substance was found out to be in the product. Like, for example, recently we had a problem with the Maggi. So what was seen, okay, we have a problem in this particular batch, we can just recall that particular batch only. If there will not be problem in any other batches, so unnecessarily we may not call those recall those batches. We will recall only that particular batch which is having a problem. So it should be written over there. Now, very important, that is the barcodes. You see, we have barcodes available on to the products. And how should we go for the calculation of those barcodes? That's very important. Usually, the system that we are following here is that European article number 13, EAN 13 barcode. It is a 13-digit number. 13-digit include 12 data and 1 check. The last digit is called a check. So it is a superset of the original. Previously, we had 12-digit universal product code system, but it has been now changed to EAN 13 system. So in how we go for the calculation, as I told you that the last digit is the check digit. So a check digit is the result of the mathematical calculation performed on the preceding digits in the number. You have some 12 digits, then the last digit is to be calculated mathematically. So that is what we call as modulo 10 algorithm. So how do we calculate it? I will just show an example. So you have an example in front of you. Calculate the check digit in the following. You have 12 digits in front. Then you add the last, you have C. This is check digit. This you have to calculate. So how do we go for its calculation? Step first is you have to start with the first number on the right. Leave C aside. Start from the first number on the right. That is 3. Add all the alternate numbers. So we will start from 3, then we will see the alternate numbers, we will add them. That is 3 plus 0 plus 2 plus 0 plus 4 plus 9. That is 18. Step 2, we have to multiply we have to multiply resulting with 3. Okay, this is to be multiplied by 3, so it comes out to be 54. Then starting with the second number on the right, then we have the second number on the right, that is from 3, that is 0. So we will add all alternate numbers, that is 0 plus 1 plus 0, 0, 0, 8, that is 9. So adding step 2 and step 3, that is 54 plus 9, that comes out to be 53. Then we have to add such a number so that we can get the next multiple of 10. For example, the next multiple of 10 from 63 would be 70. So we have to add 7. So this 7 would be the check digit. So the barcode for this would be 9040002100377. 7 would be the check digit. So this is again that I have kept it here. So we can calculate it for this also. So you have to add alternate numbers. You have to add alternate number, multiply by 3 for the first step, then add the number so that you can reach the next multiple of 10. And the less commonly used, since I told you we have EAN 13 barcode, then we have EAN 8 barcode system also, and that's used for making retail goods, and that's usually made for smaller items like we have confectionery items. So it's not possible to have a very big label over there, so you can just use an EAN 18 barcode system over there. So this is our recently published book, that is Testing Procedures of Food Packaging Materials. That's from our in this you have each and everything written over there, the calculations about the barcodes and labeling. Then best before date and use by date, that's very important. That should be mandatorily there. So labels must carry that I told you, and as I told you, label should be in English or Devanagari. So this is the label in front of you. This is another Apalam. So you have in Hindi as well as English. You can keep both language, or you have to mandatorily keep either of the one. That I discussed it. This is so labeling requirements. Trade name should be there. List of ingredients has always to be in the descending order. That means the ingredient which is present in largest quantity, that should be at the number 1. Then on the second number there will be, so it should be in the descending order of the quantity. Okay, very important. If you have any ingredient which is made up of 2 or more products, so you have to mention the 2 or more products. You have to mention those products of which this ingredient is made up of. Except if it is less than 5%, then it's not mandatory to be shown. But if it is more than 5%, its quantity is more than 5%, then those ingredients or compounds are to be shown. One more important point: if you are adding water, that added water must be included in the list of ingredients, except for some of the products. Like if it is written brine, brine comes to our mind, brine means salt in water, syrup means sugar in water, or broth. So it is clearly understood that water is present. So in that particular case, you don't mandatorily need to mention water, but apart from this, you have to mandatorily mention the added water. So nutrition information, as I told you. Okay, nutritional information has to be per 100 gram basis or per 100 ml basis. And energy value should be in kilocalories, protein, fats, and carbohydrates, that is macronutrients. They have to be in grams. This is important. Then you can have mgs and all about all other vitamins and minerals or micrograms. Okay, if you are claiming about saturated or unsaturated fats, that should be there. Monounsaturated, polyunsaturated fats, you have to mention. So like a label you can see in front of you. Okay, trans fatty acid percentage, you have to mention. It has been made mandatory now, because trans fats are usually formed during hydrogenation of vegetable oils, and hydrogenated vegetable oils are being used frequently in the industry. So there is possibility that trans fats are present over there. Okay, nutritional information is not necessary in case of in some products. It's not mandatory or it's not necessary to have the nutritional information. Like for example, raw agricultural products. We have apples, we have pear, we have grapes. So it's not mandatory to go for them. It's not mandatory. Table salt, not mandatory. Sugar, jaggery, non-nutritive foods, packaged drinking water, alcoholic beverage, fruits and vegetables, pickles, papad, ready-to-eat food, food shipped in bulk which is not for sale as such. So for these, labeling is not important. Now, trans fats. You can claim, you can write trans fat free only if trans fats are present less than 0.20 gram per serving, or you can write it as saturated fat free if it is not exceeding 0.10 per gram, 0.10 gram per 100 gram or 100 ml of food product. Health claims, you have to mention only if these are proven. Like I told you, you cannot write it prevents cancer, it lowers cholesterol unless it is proven. So health beneficial effects does not mean that you will say that it is containing vitamin and it will be having a health beneficial effect. It's containing mineral, it will be having health beneficial effect. No, it should be having a proven physiological effect. That is proven physiological effect. If you are claiming it to be anti-diabetic, it should retard the inhibit the activity of alpha amylase, alpha glucosidase in our body. It should be proven by the scientific claims. And this is the veg and non-veg logo, but it has been recently changed from circle to the triangle shape, just for those blind people or differently or spatially abled people. Food additives you have to mention, flavors you have to mention, and these are some of the symbols that are usually present onto the labeling material, like fragile, do not use hooks, keep away from sunlight. So that's all. Thank you. So I would have talked much, but since keeping time into consideration, any questions are welcome.
Thank you, sir. Thank you for this labeling and all other details as per the FSSAI norms. So now I would like to request our participants, if they have any question, they can post in the chat box or question and answer box.
Yes, sir, can we take the questions after Amarjit ma'am's talk?
Okay, ma'am. If sir is agreed
Yeah.
to that.
Yeah.
Okay. Okay.
Because
Okay.
yeah, because ma'am has joined even though she is not well today. So let's not keep her waiting. That is the reason.
Okay. Okay, sir. We'll get back with the question and answer session after Dr. Amarjit Kaur's presentation.
Sure.
So dear friends, today we are fortunate enough to have Dr. Amarjit Kaur among us. So good morning, ma'am. Welcome to MIT Institute of Food Technology and to this national workshop. So dear friends, Dr. Amarjit Kaur will be speaking on food product development in food industry today. So just to introduce her briefly, she has more than 35 year of experience and handled many funded projects, and currently she is now principal food technologist in Punjab Agriculture University. Her specialization is cereal technology, functional and health food processing technologies, and she has many reputed publication to her credit, and have handled many of the funded projects and visited many countries to promote this milling technologies and food technology to the scientific community. With this brief introduction, I would like to invite Dr. Amarjit Kaur for the talk on food product development in food industry. Over to you, ma'am.
Thank you, sir. In the beginning, I would like to thank the organizer, especially Dr. Modi. He was my senior in the PhD. It is nice. After a long time, he has invited me for a talk in the university he is working. So I would like to thank the Monica ma'am and Soumya Rohit also for introducing me. And now I would like to share my presentation.
Ma'am, actually, you are not audible.
Ma'am, I think you need to unmute.
Ma'am, with the video button, there is one button of the mic actually. Please press that, then I think you'll be unmuted.
Still, let me.
Yes, ma'am.
So we are getting her voice, but it is low. Yeah, yeah. It is
I
low.
unmuted it.
Ma'am,
Now
if you are using your mic or headphone, please eject it.
No, I am not using my headphone.
Now it's clear, ma'am. Now,
It is
yes.
clear. It is
It is
clear.
clear now. It is clear now. Yes, ma'am.
I have to share my PowerPoint.
Yeah, yeah. It is sharing.
Is it visible now?
Not yet, ma'am.
Is it visible
No, ma'am, it's not visible now.
now?
Not visible. I think you first open the presentation, then
have
start sharing.
I have shared it now. I can check it again.
Visible, ma'am. There is one this thing slide, but that slide is totally blank.